Hey, what's up guys? So today I'll be making and designing a power supply. So my goal of this power supply is to make it cost effective and viable for most hobbyist projects. The specs I want for the power supply are a voltage range of 1.2 to 17 volts, with a current range of 1.5 amps, and an adjustable voltage and current limiting features. So let's get started. The four main components we will need are the LM317, and this is an adjustable voltage regulator with a max output of 1.2 to 37 volts and an output current of 1.5 amps, meeting our desired current levels. Then we will need an LM7805. This is a fixed voltage regulator that gives us a steady 5 volt output. It also has a current rating of 1 amp. Finally, we'll need an ATtiny85. This microcontroller will be the brains of the project, powered by Arduino, keeping things simple and reliable. First item we need is the LM317. All you have to do is put the input to plus 20 volts and the output leave it open because that is the output to our power supply. Next we need to create an adjustable voltage divider connecting to the adjustable pin on the LM317. Changing the position of the potentiometer creates a variable voltage drop. This voltage drop tells the LM317 what voltage to output. I will make the first resistor R1 390 ohms and R2 a 5K potentiometer. These values are calculated by the equation on screen. Then add two capacitors, one on the input and one on the output. These smooth and filter the voltage. The capacitor values are also given in the datasheet. Great, now the adjustable voltage is complete, let's add current limiting. The first step to limiting the current is putting a 1 ohm resistor on the input of the LM317. This resistor is a current sensing resistor and 1 ohm makes the math super easy. Next we have to add an op amp to the circuit. If you don't know what an op amp is, I'll be making a video on it soon. Otherwise, I suggest a quick Google search. But we'll be using this op amp to create a differential amplifier. A differential amplifier will measure the voltage before and after the resistor. If you take the voltage before and after the resistor and subtract, that will get you the voltage drop on the resistor. Finally, the differential amplifier spits out the voltage drop on the op amp's output. If you want more of an explanation of the differential amplifier, I will be making a video on it soon. The output voltage of the differential amplifier will be the amps flowing in the circuit. This is because we know the voltage across the resistor, and the resistance of the resistor is 1 ohms, so using Ohm's law V equals I times R, or you can see on screen, we can calculate the current. For example, if I have 1.5 amps flowing through the circuit, the voltage drop would be 1.5 amps times 1 ohm, which would be a voltage drop of 1.5 volts, which is the same value of the current flowing. Next, the output of the differential amplifier will be connected to a positive pin of the op amp. This op amp will have no feedback and will be used as a comparator. The negative pin of the op amp will be connected to a 0 to 1.5 volt adjustable source from the microcontroller. Next, the output of the op amp will be connected to a transistor. This transistor will connect the adjustable pin of the LM317 to ground. But back to the 0 to 1.5 volt source from the microcontroller. This will control the current from 0 to 1.5 amps. So how it works is, let's say the microcontroller sends a 1.5 volt signal, and the current flowing through the circuit is about 1 amps. So the differential amplifier will send a voltage of 1 volt. Then the comparator will give a low signal and the transistor stays off. This low signal is created because the 1 volt signal coming from the differential amplifier on the positive pin of the op amp is less than the 1.5 volt signal coming from the microcontroller on the negative side of the op amp. Using it as a comparator, this will create a low signal that will keep the transistor turned off. But let's say the current spikes to 2 amps. So if the differential amplifier spits out a 2 volt signal, then the comparator, because the signal coming from the microcontroller is only 1.5 volts, will send a high signal, turning the transistor on and shorting the adjustable pin to ground. This will lower the voltage on the output of the LM317 and decreasing the current flowing. Next we will add the LM7805. This IC will give us a constant 5 volt output with 1 amp current flowing. This IC will power our microcontroller and our op amps. We will also add a USB connection because this is a 5 volt signal and that's what most USBs are powered by. Finally, add the 0.33 UF capacitor on the input and a 0.1 UF capacitor on the output. Finally, we will add the microcontroller. For this project, I will use the ATtiny85 due to its small size. First, you have to connect the ATtiny85 to voltage and ground. Make sure the voltage is not the input signal that is about 20 volts, and make sure it's the 5 volt regulated voltage that we just created. Next we will connect pin 6 to the negative 0 to 1.5 volt input on the comparator. This will set the current. After that, connect pin 2 to the positive end of the comparator. This will measure the current flowing in our circuit. To measure the voltage, we need a 4 to 1 voltage divider to cut off the output of the LM317. For this, I will make R1 3k ohms and R2 1k ohms. The final step is to get visuals of the voltage, current, and set current limit. To do this, we will use a serial LCD. Connect the SDA pin on the LCD to pin 5 of the Arduino, and connect the SCL pin of the LCD to pin 7 of the Arduino. And that's the basic schematic of my homemade DC power supply. To power the 17 volts to the circuit, I will be using a wall wart from an old laptop. Just make sure the wall wart has at least 3 volts higher than your output voltage of the power supply. Anyways guys, thanks for watching. If you enjoyed the video or even learned something, please leave a like and subscribe.